a breakdown of our models. Hopefully this will be helpful for you in determining the best solution for your application. So before I dive into our signal generators, I would like to quickly touch on us, Berkeley Nucleonics as a company. Now, we've been in the business for over 60 years. Today, we have 3 divisions of our company, RF microwave, obviously, test and measurement, that is for our pulse generators, delay generators, and oscilloscopes. And finally, our nuclear division. We offer isotope identifiers, personal radiation detectors, scintillation detectors. The list goes on. But our motto is basically, if there is a signal in this world, we would like to provide the capability to analyze these signals. To continue about BNC, our corporate headquarters are located here in San Rafael, California. We do have additional facilities, both manufacturing and sales, all over the world. But here in the U.S., you may have been invited to this webinar from one of our local representatives in your area. So with that, I say thank you to our local representatives and thank you to the customer for joining us. Please continue to work with your local representative, as we are very confident they will provide great support for you on our behalf. Now, today we are one of the recognized leaders in the microwave space. We have very, very innovative solutions, including our signal generators, synthesizers, dedicated phase noise testers, all designed to be used in many different types of environments, whether it's automated, lab use, or even field use. So let us dive right in. First is a very, very basic question, and many of you already know the answer. But, humor me, right? An RF signal generator is basically a piece of test equipment that will produce a continuous wave or CW wave at a defined amplitude or frequency. Now, many models, they offer, some type of analog modulation, either as standard or as an option. And if you look at the bullet points down below, the first term says signal source, and that is a very, very common term in the industry, whether it's a synthesizer or a signal generator, but very self-explanatory, right? What is the source of your signal? Now, in every case, a frequency and an amplitude must be defined, or else it will not be a signal source. And to touch on the difference between RF and microwave, radio frequency goes up to usually 6 gigahertz. Microwave covers a larger bandwidth, at least going up to 20 gigahertz or more. Now, the purpose of a signal generator, it's basically to simulate an RF or microwave signal. They are used for testing components, receivers, and test systems in a wide variety of applications. This can include radar, cellular, Wi-Fi, satellite communications. Any type of wireless communication, you will most likely require a signal source for your testing. But again, you're not limited to just communication. We actually have a customer, a very, very large university, who is using our signal source, our 40 gig signal source, to heat up plasma, right? So if you can imagine sending out a signal, a 40 gig signal, adding a substantial amount of power to it within a chamber that goes through a waveguide. It hits the plasma. It'll heat up the plasma. Now the researchers can analyze the results. So again, you're not just limited to communications. There are many, many different types of applications where a signal source is required. So choosing the right signal generator, this is the important part of the webinar here. We understand, and there's no question, it can be quite time consuming to find the right solution for your application. So the first question you must ask yourself is, what are my requirements, right? And if you see the list below here, I've made a list of requirement specifications that the majority of our customers really care about. Right. So the first one here is frequency range. Obviously, what frequency range do you need to attain, whether it's on the low side or the maximum frequency. Power range, again, very important. What's your minimum power that you require or the maximum that you require? Switching speeds, is that important to you? Phase noise floors, harmonics, spurious, are those specs important? Do you require modulation or just a CW source? Is this going to be lab use only, or are you planning to move it around to different locations or maybe even field use? So yes, during this webinar, we will break down each of these specifications and look a little bit more. We'll focus a little more on each and determine if it's important for you or not. Now, just as a quick reminder, Berkeley Nucleonics, we offer many, many different models, many different specifications, form factors, enclosures, so that we may be able to provide a viable solution regardless of application. So the first requirement, frequency, very self-explanatory. First, what is the range of the frequency that you require? The maximum and minimum output frequencies. What is the resolution? That means what is the smallest frequency change, or how small of a step can you provide to change your frequency? And in our case, our frequency resolution is 0.001 hertz, very, very fine. Accuracy is very important as well. That just means, how accurate is that output compared to what frequency you actually set. Our frequency accuracy, you see on the chart below, minus 100 plus 100 parts per billion. Stability, very important as well. Let's say you're needing to run a signal overnight. So when you come back to the lab the next morning, you take a look at that signal. Hopefully it is identical to the signal you saw the night before. Our aging per day, again, 5 parts per billion. Very, very stable signals that we provide. The next specification is the power. This could also be quite one of the most important specifications we get asked. And that's due to the fact that the power is very important for many, many different types of applications. Now, depending on the manufacturer and the model, this can range from minus 135 to plus 30 dBm. So let's give you a couple of examples on when low power is needed and high power is needed. So for, let's say, cell phone receivers, right? If you are trying to test the sensitivity of that receiver, you will need, for example, most likely minus 120 dBm. But on the flip side, for high power amplifier testing, you will need between plus 15 and plus 20 output, due to the fact that many of these high power amplifiers have an input threshold of about plus 15 to plus 20. So if you look at the chart right below, this kind of breaks down the power ranges of each model. The 835, again, this is our lower frequency entry level model, but the range is very good, from minus 120 to plus 17. And, the list goes on here. If you look at the 865, we can even get a little bit higher power at plus 21 from minus 90. So again, we like to have many, many different types of solutions, many different specifications to be able to fit the majority of applications out there. Okay, so the next specification is switching. Now, this could be quite important for your application as well. Frequency switching, or amplitude switching, or waveform switching. How fast you can switch between frequencies will vastly influence your testing. So, for example, let's say antenna testing, right? This antenna must be measured at many different angles, right? So for each angle, you are going to have a list of frequencies that you wanted to measure, right? So the faster switching speed that you have, it can sweep through that frequency list much quicker. Therefore, being able to do many more measurements in the same amount of time. That obviously will kick up productivity. You'll be able to test many more antennas. And even besides that, for any other component, again, switching speeds can be quite beneficial for you. So if you look at the chart below, this will give you the specs of what we can provide, right? Our, again, 835 or lower end model will provide you about 400 microseconds of switching speeds. But if you move up, we do have an option FS, which is the fast switching option. That'll reduce that time to about 40 microseconds, even 30 microseconds with our Model 865. So as mentioned, if that productivity, that the speed of measurements, how many measurements you can do in the same amount of time, if that is important to you, then the fast switching option may be a benefit if you're looking at our solutions. Phase noise. This could be one of the most important specifications. We get this question all the time. Now, if you've joined us for our past webinar regarding phase noise, you would know that phase noise is basically a random fluctuation of amplitude or frequency. So basically, noise or phase noise is going to determine how good of a connection that you will have. The worse phase noise is, the worse connection, right? So ultimately, having the lowest phase noise is quite important, especially for communications or RF designers. So if you look at data sheets for any signal generator on the market, right, you will notice on the phase noise portion of that data sheet, SSB. That basically stands for single sideband phase noise and is always expressed in dBc over Hertz. Now, with LO duty applications, especially LO applications, that phase noise is very important. That's due to the fact that that phase noise spec that you see on that data sheet will be added to the signal of your system. So if you are down converting an RF signal during frequency conversion, now you have that added phase noise from the LO itself. So if that LO is excessive, then again, it is going to affect that connection. It'll mask that information carried on that RF signal. So if you look at the chart below, this is a snapshot again of our phase noise specs for the different models. And as you can see, minus 150 dBc over Hertz at different offsets. This is very, very good all across the board. And that's one main spec that we care about very much. And going forward, we only expect this spec to get better over time. Now, this is a plot using our phase noise tester of the Model 845, which is the green plot that you see there, and the Model 865 with the low noise option, which is the blue plot. As you can see, there is quite a difference in terms of the noise floors, right? The 845, it will go down to about minus 128.6 dB over at 100 kilohertz. The 865, you'll have about a 20 dB improvement. So again, if phase noise is very important to you and the lowest noise floors are desired, then the Model 865 with this option LN could be a great solution for you. Now, let me explain the option LN. This is basically to provide lower noise floors close into the carrier. So in this case, 1 Hertz, 10 Hertz, and these at these offsets, you can expect some lower noise floors, as that can be important for many different types of applications. Okay, so besides phase noise, what other type of noise will affect your signal, and what may be important to you? Well, harmonics and spurious emissions, this could also be important to you. Let me explain what these actually are. First, harmonics is deliberate EM radiation, or deliberate electromagnetic radiation. So for example, if you are a manufacturer of a certain device, let's say a Bluetooth device, right? You are deliberately creating a frequency. That frequency will have harmonics to follow along with it. And again, that is deliberate. So if you look at the chart on the right, you have your fundamental frequency, and then you have your harmonics that follow with it. In this case, all the way down to the sixth harmonic. And again, this is deliberate, right? You are deliberately creating an RF frequency, deliberately having these harmonics follow. But spurs, the main difference with spurs is that it is non-deliberate. It is random, right? And this is quite important to understand because, again, this is another form of noise, right? And especially in overlapping frequencies, quite important as well. As you can see between the second and third harmonic, you have these two spurs popping up there. There's two main reasons why harmonics and spurs are important. First is the FCC regulations. And as you may already know, the FCC has designated certain frequencies within a spectrum for certain devices, right? In order to make sure that none of these devices are encroaching on each other, the FCC has set limits on how much emissions that your device can radiate, right? And if it's an intentional radiating the device, you must stay within the limit that the FCC has put in place, just to make sure all of the devices are working correctly. Nobody is jumping in on each other's territory, and a device is not working correctly due to the fact that another device in that area is sending out emissions. The second reason why it may be important to you, let's say that you are well within the FCC regulations, right? But as a designer, the spurs still may have an effect on the performance of your product, right? So let's say, for example, a receiver, a very sensitive receiver, right? At certain frequencies, at certain power levels, you may see a spur that will drown out that signal your receiver is trying to detect. So again, you may be within that FCC regulation, but if you are having these spur emissions affecting the detection of a signal, obviously that's something that you want to mitigate and realize, right? Now, in general, the way to mitigate harmonics and spurs is to use an external filter of some sort, right? But we understand that that might not be as viable for many customers, whether it's due to the additional cost or the space. If you are integrating, creating a system with integration, having external filters may not fit very well, right? So we understand this, especially from customer feedback. So we've developed our own solution here, which is the Filt option. And that is basically built-in internal filters with our signal source. So if you look at the chart below, we have our models broken down again. But on our model 865, we have an additional spec here, option Filt, and that will dramatically reduce the amount of harmonics. As you can see, from minus 40 dBc, now you can attain minus 60. So we're very excited about this new option because, again, many customers have requested a solution of this sort. So now we are, again, very excited to offer this. And if this is something that, or harmonics or spurious emissions is something that is troubling for you, possibly our 865 with this option could be a solution. So moving on, the next specification, right? Number one question is, do I just need a CW source with very low phase noise, or do I need some type of modulation? So again, BNC, we like to provide all the solutions possible, right? So with modulation, we provide a breadth of solutions here. As you can see from the chart below, AM, FM, PM, pulse, chirp, the list goes on. Of course, you will not see digital. This is all analog modulation. That is another topic that we will cover in the future. But these two images that you see here, the left is, again, snapshot of our signal generator with the amplitude modulation. On the right is a pulse train that we created with our pulse modulation using the Model 845. So, example applications. Now, I've chosen two applications here as they are vastly different from each other. Radar, I've chosen radar because phase noise is one of the most important specifications that they care about. But for signal path loss in 5G field testing, it is quite the opposite. Phase noise, not so much, but power is the most important specification. So let me kind of dive into each one of those. So for the radar application, you know, your target, it requires some high resolution. And in order to attain that high resolution, you need very, very low phase noise. Now, for example, a Doppler radar system, right? In Doppler radar systems, you are sending out a signal. That signal is going to reflect off of your target object. You're going to receive it. You're going to analyze the Doppler shift of that frequency to determine the velocity or distance of that target object. But if for slow moving objects, that Doppler shift is going to be much smaller, right? So if the phase noise of your source is higher than the amount of power that is coming back on that reflecting signal, then you will not be able to detect that slow moving object. So again, in radar, phase noise, you know, whether it's close into the carrier, all the way across the offset frequency range, is very, very important because, again, the object is to be able to detect any object at whatever velocity, slow or fast. Now, on the flip side, 5G field testing. And thank you, Mr. Kamel, who has helped me with this as well. I do appreciate that. Well, in 5G testing, or more specifically, signal path loss, right? Phase noise is not quite as important. You know, of course, we're going to cover the frequencies, you know, the sub 6 to millimeter. But instead of phase noise, power, higher power is critical, right? Since they are measuring the path loss, right? So, for example, you must have at least 15 dB power from the transmission side because you will most likely have about a 60 to 70 dB drop by the time of reception. You can also characterize building materials. For example, we have a very large customer who is testing an NFL stadium. And you can imagine the area of this NFL stadium, how much ground you have to cover to test out, you know, how strong the signals are in each different area, right? So if you are sending a signal through a wall, and let's say this wall is made of wood, you can determine, all right, characterize this material for this type of material. When this signal goes through, this is the type of loss that you should expect. So very important as well to have that high power to determine which materials will affect. Now, another major factor that is quite important is the portability for this field use. You know, since they are covering all this area within the stadium, you know, using a traditional benchtop signal generator may be quite cumbersome, you know, and maybe quite time consuming as well for moving from one area to the next. So portability is crucial. Programmability as well is crucial. Being able to program the unit from, you know, the front panel if need be, on the fly, boom, boom, and being able to send the signal very quickly that way, or even remotely if you would like to use that route. We can help you with you know, all types of programs and programming languages. Another very important specification is the frequency switching. As we talked about before, faster switching speeds will allow you to do many more measurements in the same amount of time. So if you can imagine this football stadium, this large area, you have to move from one area to the next, and you have all these frequencies that you need to go through. Having that fast switching speed will allow you to cover a much larger area in the same amount of time. Okay, so moving on, we are talking about, signal sources and just in general, but what if you require multiple signal generators, right? Possibly having multiple channels in one form or one unit may be a better solution for you. So with this in mind, we must also mention our multi-channel solutions, our 855B. We have a very slim 1U 19-inch rack mount form factor with 4 channels. We can even increase that to 8 channels if you look at the image to the right here, which will bring it up to about a 3U instead of a 1U. But again, having 8 completely independent outputs for a signal generator is quite impressive. So I mentioned each channel being completely independent. Each one is an independent source in itself. So you can change any parameter that you wish, right? Whether it's frequencies, you can have different frequencies for different outputs, all outputting at the same time, different power levels, different modulation. For example, you can have CW out of channel 1 going out at 30 gigs, but channel 2, you have a pulse train going out at at 25 gigs. So again, completely independent, but the specifications and features are all there for you as our single channel units. Very, very low phase noise, again, minus 150 dB, and output powers can range from minus 90 to plus 25 dBm. So, oops, I think I skipped a little too quickly. I think you guys are tired of my voice, hearing me talk for so long that I'm going to give you a little bit of relief right now and introduce John Lauder. He will join us and speak a little bit more about phase coherency and the benefits with our multi-channel units. So with that said, John, the floor is yours.
Well, thank you, Junior. And hello again, or hello and good morning, or good afternoon to everyone. Quickly, for our multi-channel signal generator, we have the feature called phase coherent switching or phase memory. Again, the multi-channel is a phase coherent on all channels, so phase coherent switching as well, and it's very important for quantum computing, antenna testing, or maybe some radars for linear FM CW modulations. And in addition to the phase coherent of the multi-channel, it also has a good channel-to-channel isolation down to about 90 dB. So what is the term phase coherent? Phase coherent are the signals or systems operating at the same frequency with a consistent phase relationship. It doesn't really matter if the signals are in phase or out of phase, as long as the two signals has a constant phase difference between each other. So why is it important? Again, think of the signals as a vector or waves. If they are coherent, they will add up constructively or have a predictable output. If they are non-coherent, the two signals may cancel each other, or some fading occurs, or some unpredictable outputs. In quantum computing, one of the best examples or application of phase coherence, coherence is very important in the study of the interaction of qubits. As you know, quantum computers are prone to errors because of decoherence. In addition to phase coherence, again, it's a Model 855 is a phase memory, of which it will maintain its phase if it's in case you change frequency to the other frequencies. Here I have some couple of images demonstrating or showing a phase coherent and a phase memory. The one on your left, the one on the left is a phase coherent switching. It's a two signal. We can say channel 1 and channel 2. With initially they are at the same frequency, though a different phase. On the signal 2, at certain time, the signal 2 is changed to a different frequency, which is the red, and then changed back to the same frequency. With a phase coherent device, the signal 2 will remain at the same phase with respect to channel or signal number 1, the blue signal. The image on the right is a phase memory example. Imagine that this is just one signal. The blue is our reference, or say if we never change frequency, and the red one is the signal if we change frequency. So again, at that time where we change the frequency, the imaginary signal never changed frequency, and then if we go back to the same frequency again, it will remain in phase, just like we never change frequencies. We also prepared a quick video or short video explaining the phase coherence and differentiating non-coherent signal generators. Let me play that quickly.
Good morning. Today we're going to show you the importance of phase coherent or phase matching on a multi-channel signal generator. The unit you see here is the Berkeley Nucleonics Model 855. It is a phase coherent multi-output unit. The unit features fast switching and low phase noise, and the unit is capable of up to 40 GHz of RF output. Please note that not all multi-channel signal generators are phase coherent. This is a one-of-a-kind feature of the Berkeley Nucleonics Model 855. What you see here is what is commonly done to achieve a multi-channel signal generator. In this diagram, you can see two signal generators. Signal generator number 1 is connected to channel 1 of the oscilloscope, and signal generator number 2 is connected to channel 2 of the oscilloscope. The clock out of the first signal generator is also connected to channel 4. The clock out is used as a reference, so here we use it as a trigger for our oscilloscope. Here you can see two signal generators that we are using. The signal generator on the left is signal generator number 2 in the previous block diagram, and the signal generator on the right is signal generator number 1. Both signal generators were connected according to the block diagram previously seen. Here you can see the oscilloscope outputs, with the rightmost signal generator being channel 1, and the leftmost signal generator being channel 2. Also note that the channel 4 input on the oscilloscope is the clock output of signal generator number 1. If we turn on the output of the signal generator number 1, we can see that the output is in phase with the clock input on channel 4. When we turn on the output of signal generator number 2, we see that the RF output is what we call walking. This happens because the two signals are not in phase or exactly alike. As you can see here, both signal generators are set to a 10 MHz output. For most applications, what most users do is to connect the clock output and input of the two signal generators together. Currently, they are not connected to each other, and as we can see, the output is a little odd. To show how this looks, let's go back to the block diagram. As you can see, the clock out of the master signal generator, which is signal generator number 2, is connected to the clock in of the slave, or signal generator number 1. With both signal generators connected, we go into the settings to deal with the walking issue we saw earlier. Now that we have both signal generators connected via clock in and clock out, we go to the settings and see that both signal generators are currently synchronized to their own internal clock sources, and both units are set to their 10 MHz clocks, but they are not synchronized. If we set signal generator 1 to external, you will see that the RF output is now synced on the oscilloscope. As you can see from the oscilloscope output, both channel 1 and channel 2 are synchronized, but the problem exists now that their phases are not matching. Now, you can use the phase settings on our signal generators to correct for that, but the problem still exists that every time you change the frequency of one or the other, the phases are no longer aligned when you go back to the same frequencies. So no matter how many times you do it, you may get lucky, but they're not matched. And as you can see from the video, we correct the phase and then change the frequency and then change the frequency back to matching, but the phase is no longer matching, and that's the issue we have to deal with now. And as you can see, this is fairly consistent with any channel we make the change on. So if we make the change on the other signal generator, and we change the frequency there, and then back, we still have to align the phase to get a proper matching phase on both of the channels. So as we see off the outputs of the oscilloscopes, unless we want to change the phase each time we change the frequency of the signal generators, one of the main ways to compensate would be to have a signal generator that is phase coherent. Now we're going to show you what the signals would look like with the phase coherent signal generator. So give us a second while we hook up our model 855 and show you that. As you can see, we disconnect from our previous signal generators and we connect our model 855. Notice how now the system has 2 channels selected, as the 855 is multi-channel. And as stated earlier, our model 855 is a phase coherent multi-channel RF signal generator, and you can see there's now 2 channels on the UI. And as we turn on output number 1 and output number 2, you can see that the outputs are automatically in phase. Both channels 1 and 2 are set to independently to 10 MHz with a phase of 0 degrees on both channels. And as you can see, even when we change the frequency of one of our signals, we change it back and the phases are still matching. We will now go through different iterations of frequencies and even turn off one channel and turn it back on, but every time, as long as the frequency is the same, you will see that the phases are always matching. It also doesn't matter which channel you change the frequency on, they will still both be in phase when you match the frequency. That's the importance of having a phase coherent multi-channel signal generator like the model 855. Thank you.
Okay, thank you. Again, I will transfer you back to Junior and talk about the difference between a synthesizer and a signal generator.
Thank you very much, John. And before I move on, I see all these questions in the chat box. Thank you. Please continue to type in any questions that you may have. I should have mentioned this in the beginning. And thank you to Dak Singh as well. He is working very diligently to answer everyone's questions. But I will remind you at the end of our webinar, we'll have a Q&A session as well. So, if by chance your question does not get attended to by Dak Singh during the webinar, we will definitely get to it at the end. So moving on, RF synthesizers and signal generators. I'll personally get this question a lot as well, since we offer both solutions. What is a synthesizer compared to a signal generator? So let me kind of break down the definition of a synthesizer. It's basically an electronic circuit that generates a range of frequencies from a single reference frequency. It may use many different types of techniques, from frequency multiplication, division, direct digital synthesis, mixing, PLLs to generate its frequencies. Now, the main difference between a complete signal generator, quote unquote, and a synthesizer is that the signal generator provides added features like parameter sweeping, extended modulation capabilities, a wide dynamic range and power output, fine amplitude setting capabilities, enhanced harmonic filtering. Basically, you have much more capability with a full complete signal generator. Synthesizers are generally lower in cost at the same frequency. So if you were to take a look at our 40 gig synthesizer versus our 40 gig signal generator, you'll notice the price difference. But you'll also notice, as I just mentioned, the different types of features and functions that may be missing from the synthesizer. But again, this will determine, or this all depends on your application and your requirements to determine if a signal generator or a synthesizer is of good solution. So staying on this topic here, in general, signal generators will have an adjustable output power at a certain resolution, very, very low harmonics, and the host of modulation capabilities, and either internal or externally triggered. Now, synthesizers, they usually have a fixed power output. You will not be able to adjust it. And if you can adjust it, it's usually a more coarse step versus a signal generator. Usually never a front panel for controls. It's only controlled through PC, so it must be remote. Switching speeds may be pretty good as well, since there are much less components in the synthesizer architecture versus a signal generator. But modulation is normally very limited. In our case, we do provide pulse modulation, both internal and externally triggered. But yes, that would be the one spec that you will probably see the biggest difference in between a full-on signal generator versus a synthesizer. Now, let's take a look at a plot comparing a signal generator and a synthesizer. We have our model 845, which is our unit that goes up to 26 gigs. It's right in the middle of the pack there. Then we have our synthesizer version, the 845-M, that will go up to 20 gigs. And if you compare the phase noise plots of both, right, the red line is the signal generator, the yellow line is the synthesizer. Very comparable, very similar in phase noise performance. Actually, in some offsets, the phase noise of the synthesizer may be a little bit lower. But again, that is one spec that we really care about here at Berkeley Nucleonics. As I mentioned earlier, phase noise in many different types of applications, especially in communication, will affect your results. So we will continue to improve, expect some better numbers in our future iterations. But even today, minus 150 dBc is quite good on the market. So this is a snapshot of our module synthesizer. As a matter of fact, I don't know if you can see the video. If you look at the screen with my face, I'm just holding up our 865M 40 gig synthesizer. Very small, very compact, very lightweight, weighs about 2 pounds, right? This is a single output device. You have your RF out, is an SMA connection, and then you have all the other connectors for your reference or reference in and out, trigger, pulse, and so forth. Those are BNC connectors. But again, I just wanted to show off the size. I would say it's about the size of a little bit bigger than an external hard drive. but again, very portable. But since I'm showing you that, I must also show you our signal generator, our benchtop signal generator. All right. Now, again, this is not the same form factor you would expect from a traditional benchtop, right? This is quite small as well, the size of a lunchbox, designed for field use or moving from one location to the next. It has a handle on the side, weighs about 5 pounds, very light. And also, because we know you may take it out into the field, we have these bumpers that are available that come with every unit. So it'll be able to handle some bumps and bruises a little bit better. And also a battery option. We have an internal battery and external battery option. So if you're out in the field, you will not need to have a separate power supply, right? It gives you much more usability, and our batteries have been rated to last up to 15 hours on full power mode. So the image on the right you see there is our multi-channel version of our synthesizers as well. And the enclosure is exactly the same as our multi-channel 855B signal generator. And very slim, rack mount, 1U, 19-inch. You can have up to 4 channels in one unit. This is a 4-channel unit that you're seeing right now. So again, depending on your needs, you may not require all the modulation capabilities. You may not require fine steps in power adjustment. If that is the case, the synthesizer may be a great solution for you, because again, it does still come with great phase noise specifications. And these are just the dimensions. If you wanted to see the actual numbers of how large or small our solutions are, the single channel generator again weighs about 5 pounds. In this case, 2.5 kilograms, between 5 and 6 pounds. Again, size of a lunchbox. Even smaller with our single channel synthesizer that I just showed off. And again, internal or external battery options to make it much more user friendly out in the field. Must highlight our GUI as well. I know in the video you saw some controls there on changing some parameters. I'll just quickly go through each of the tabs that you would see when you download the GUI and open it up on your PC. So the first screen you see here is very simple. It's just going to show you all of the devices on your network that this software can control. So in this case, there are 3 different signal generators. You choose the one that you want to control, and it'll automatically connect to it. Once you're connected, then you have your choices of what type of parameters that you want to set. Is it just CW? Then if you want to click on the CW tab, set your frequencies, set your power, set your phase. You click that RF off. You click that RF on button. It should be green when it's running, red when it's off. The screen on the right, snapshot, will show you the modulation capabilities. There's a modulation tab. In this case, we've chosen pulse. Again, very simple. You just set your parameters, your width, and so forth. And then you can just click go. On the bottom here, this is for the sweeping. We talked about switching speeds, sweeping speeds. This is where you would enter in the sweep parameters, right? References again as well. Our units are designed to work with an external reference. So you would choose a reference tab here to set that the frequency of that external reference. And finally, the trigger, right? We also have external trigger capabilities. This is where you would come to set those parameters. But again, these are just a snapshot. You may see that once you have your unit in hand and you've downloaded the GUI, there may be many more features and functions that you did not see before. And I mention that because we are always continuing to improve our software, and that's all from customer feedback, right? We as a company, we like to reach out to our customers, especially myself as a product manager, to find out what you like about our instrument. You know, is it just software that you have problems with? What do you like about the software? What do you dislike about the software? What are your suggestions? Let me take them into account and see what we can do for the next update. So yes, if you are a customer of ours, please feel free to let us know your thoughts, your experience, what you would like to see in the future, because that vastly helps us develop better products, better updates. We're almost to the end here, but must mention our comparison charts. You know, again, I know we have many different models of signal sources on our product line, so we try to make it as easy as possible. So this chart you see right here is just a comparison chart between the models from our entry level 835. This one goes up to 6 gigs, our model 845 going up to 26 gigs, and then 40 with our 865. Now I must mention our 845-OEM. That is basically the internal, the board level solution of our model 845. And this is for our customers that require a much smaller footprint, possibly needing to integrate within their system. And they would like to, create their own software to control this unit as their own product. So yes, if this is something that is on your mind as well, something that you have to deal with, please let us know. This may be a good solution for you as well. But yes, this comparison chart is available on our website. At any of our signal source pages, if you go to the bottom of each web page, there will be a resource portion where you can download documents such as a comparison chart like this, or the data sheet, white papers, app notes, etc. Same thing goes for our synthesizers. We have these broken up as well for easy understanding. You know, we have an actual new product in our lineup here. It's the 825-M synthesizer. This is going up to 20 gigs, and you know, may not have the best specs compared to the other units here, but again, we want to have a full breadth of solution for all the different needs out there. So this one again goes up to 20 gigs, decent specifications. Your phase noise, again, we want to be at -150 or better. That's all there for you. And then moving on up, you know, all the way up to the 865, we have our 40 gig synthesizer. And again, if you do not require the extensive modulation capabilities or the fine power adjustment, possibly the synthesizer was a better solution for you. So, in conclusion, how to choose the correct signal generator? Well, there's many different questions, right? The requirements. Once you've determined your requirements, and let's say you even found a solution that fits those requirements, you must also ask yourself, is this going to fit my future applications? You know, as we know, frequencies are constantly increasing year over year. Power levels may also need to increase for different type of applications. You may want to think about having a future-proof solution, right? Future flexibility. Or do I need multiple units, right? In that case, maybe a multi-channel solution would be a better solution. So again, BNC, we think all across the board. We want to have a viable solution for every single type of application. And if by chance you do not see something in our product line that will fit you, please let us know, because that is one of our other strengths. The capability to customize and develop a specific solution for a customer. We do this quite a bit every year. We have very large customers that come to us with their specific requirements in mind, and then we have come back and designed a specific solution for them, and it's been quite successful. And then with that said, let us do that for you as well. So that sort of does it for me, does it for John Lauder. Thank you very much again